Hi everyone. Today we're going to look at a couple of problems that deal with how we construct sinusoidal functions. Okay, so how do we construct sinusoidal functions? So the first problem we're given here is the graph of a sinusoidal function intersects its midline at 0, 1, and then has a maximum point at 7 pi over 4, comma 5. Write the formula of the function where x is entered in radians. So what I did was I just copied the important information here, and obviously the important information is the midline, 0, 1, maximum point, 7 pi over 4, comma 5. Okay, so here it is, and they want us to write a formula for this particular function. Okay, so let's see how we can do that. Again, the most important things we need, of course, to write our function are the amplitude, correct? We need the amplitude. It's an m, by the way. Okay. We need the midline. Okay. We need the period. So in using the period, we need to calculate what the frequency is. Okay. Now, if you recall, I gave you the formula for period. Period is equal to 2 pi over the frequency, correct? Well, we know that if you were to transpose this equation, let's say we wanted the frequency instead of the period. We knew the period and we wanted the frequency. We could just swap these two variables and get another formula for frequency. It's 2 pi over the period. Okay, like that. And we know that the amplitude, the midline, and the frequency are all going to be in our formula, correct? Our formula is going to look something like this. So if they wanted an f of x, they would say f of x is equal to, of course, we need the amplitude, right? And then it's either going to be sine or cosine, right? So it's either going to be sine or cosine, correct? And then we're going to have, of course, the frequency times x, like that. The frequency, and you know what? I'm going to call the frequency, I'm going to give a frequency a different letter, okay? Because f represents the function. So let me call the frequency b. Okay, I'm going to call it b of x, like that. Okay? And then, of course, we have our midline, right? And I'm going to call the midline c, like this. All right? So let's call the midline c. A cosine bx plus c. So again, a is our amplitude, right? Midline I'm going to call c. And the frequency I'm going to call b. Okay? We need these three, a, b, and c, to write our function. So let's do it. First off, we have the midline and we have the max, correct? We have the y values of the midline and the max. So we know, let me change the color here a little bit. We know we can use the y values of the midline and the max to calculate the amplitude, correct? And amplitude, of course, is max minus min, right? So it's 5 minus 1, which gives us 4. Perfect, right? And now, in order to find our midline, well, excuse me, the midline is given to us, so we know the value of the midline, which we are calling now c, is right here. It's 1. There we go. So we have the amplitude, we have the midline. Now we need to calculate the period, right? In order to get the period, to get the frequency, which we need in our function, right, we need the period. So how are we going to get the period? Well, we know that the horizontal distance from the max to the midline is 1/4. It's 1/4 of the entire period. If you remember, okay, so if I were to draw, let's say the max value here, max, let's say, I'll draw it like this, sorry about that, this, okay, we know that from the max point to the midline here, this distance is only, if you count this distance here, this distance is 1/4 of the entire period. Why? Because we know the period is from max to max, correct? That's an entire period. Well, we know that from max to min is half a period. This is only now half a period, correct? Sorry. So this is half of a period. Well, then we know then from max to the midline, right? That's going to be half of half. So that's going to be 1/4, right? So again, midline to the minimum is 1/4, max to the midline is 1/4, and then of course, that is the entire period out here. This is the entire period. So, bottom line, maximum value to the midline is 1/4 of the entire period. Well, if that's the case, from max to the midline here, we're using the x-coordinates right now. So this distance, 7 pi over 4, minus 0, that's the horizontal distance from max to the midline. That's 7 pi over 4. And this thing, seven pi over 4, this is 1/4 of the entire period. So then what's the entire period? Well, the period's going to be 4 times that, right? It's 7 pi over 4 times 4. Right, we got to multiply by 4. So then the 4's cancel out like this. So now the period is 7 pi. Okay, so if the entire period is 7 pi, let's find the frequency. So the frequency, okay, the frequency which I called B, right? So let's change that. Frequency is now B is equal to 2 pi over the period. So 2 pi over the period. Period is 7 pi. So if we cancel out the pi's here, we're going to get the frequency is 2/7 right here. So these are now the 3 values that I need here. These are the 3 values that I need to write my formula. Okay, so let's write the formula now. So let's change the color to blue. We'll change to green. Okay, so my final formula I'm going to write over here. F of x is equal to my amplitude, which is 4, times, and now this thing, you notice the midline is at 0, 1, correct? 0, 1 is on the y-axis. So therefore, on the y-axis, the function starts at the midline. That shows us that this problem is a sine problem, right? Sine starts at the midline on the y-axis. If it had started on the maximum, then it would be a cosine. Okay, but since 0, 1 is on the y-axis and this function crosses the y-axis at the midline, it is the sine function. All right, so therefore It's 4 sine of the frequency 2/7 x, and then the midline, plus 1. Okay, so this should give us our function. So I'm going to type that in and see if that is correct. So let's go. Over here. It's going to be, what was it? 4 sine, okay. So 4 sine of 2/7 x. 4 sine of 2/7 x plus 1, right? Plus 1. And that is correct. Okay, guys? All right, let's do one more. Same idea, right? Now, take a look. This function has a maximum point at 0, 10. Now, this function, 0, 10, maximum point is on the y-axis. So this function starts at the maximum. So now we know that this is a cosine function. Okay, why? Because it starts at the maximum. Okay, and the midline is at pi over 4, 4. So we're going to do the same thing. Okay, so let's clear this out. Let's delete it. Delete. Okay, let's start with that nice clean board. All right. You know what? I'm going to pick a different color here. Let's pick dark blue here. Okay, I'll push that up here. All right, so let's do it. We have, what's the information? Max is 0, 10. So max is at 0, 10. So much lag here. Max at 0, 10. And the midline was at, what was the midline at? Pi over 4, 4. Okay, that's the max, by the way, guys. Okay, now, so this function, okay, it's 0, 10. That's on the y-axis. So it starts at the max, therefore we know that it's got to be cosine. Okay, so since it starts at the max and then goes down to the midline, all right, we know it's positive cosine. So this thing's going to look something like this. So f of x is going to equal, again, the amplitude times the cosine. Okay, it's going to be cosine of, again, the frequency times x, and then, of course, plus the amplitude. The midline, sorry, the midline. Okay, so first, this is the midline, that's the max. We use the y values to calculate our amplitude. So that's 10 minus 4 is equal to 6. And there's our amplitude. Okay, the amplitude is 6. So A is equal to 6. Okay, now let's see the midline. Midline is 4, right? There it is. C is 4. It's the y coordinate. So C is equal to 4. Okay, and now let's do the frequency. So frequency is equal to 2 pi over the period. Now let's see what the period is. Okay, period is, again, difference in the x values, max and midline. That's pi over 4. That's only a fourth of a full period. So we know that the period is 4 times that. It's 4 times pi over 4. And therefore we know the period now is pi. Okay? And then finally, if we write this in, if we find b, that's 2 pi over pi, which is 2. which is